Good afternoon, dear authors and invited guests. I welcome you all to the technical session 7E. Myself, Siddesh Mogal, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 9th International Conference on Information and Communication Technology for Intelligence System, ICTIS 2025, Bangkok, Thailand. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Bangkok, Thailand, and the virtual event is being held through Zoom today and tomorrow, that is 5th and 6th April 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answer. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any queries or updates, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair of the session. Our first chair of the session is Dr. Amita Sharma. Dr. Amita Sharma is an assistant professor, selection grade, CS and IT, IIS deemed to be University, Jaipur, India. She has more than 13 years of teaching experience. Her areas of interest are software engineering, networking, and security, data mining and knowledgeable discovery, database system, web services, Vedic science, and modern theories. Ma'am, would you like to give any opening remarks to the participants?
Firstly, I want to thank uh, GR Foundation for giving such a wonderful opportunity to being a part of this conference. As GR Foundation has already been a reputed name in the global world, and it has given a lot of opportunities to all the young researchers to present their work. And I really appreciate that we have such a wonderful platform where we can discuss with ourselves what we are doing, and also sort out any kind of queries if we have, and share our opinions about the different kind of research. So I thank GR Foundation for this opportunity, as well as I am looking forward to see all the presentation, and I'm really hoping that all the presentation will bring some new ideas that will also enhance my knowledge as well as all others researchers knowledge. All the best, and we can start now. Thank you.
Thank you, ma'am. Our second chair for the session is Professor Dipali Nikam. Professor Dipali Nikam is an associate professor and head of CSC Data Science Department at DY Patil Technical Campus, Faculty of Engineering. With extensive experience in academia, she is dedicated to fostering innovation and research in data science. Her expertise includes data analytics, machine learning, and computational intelligence, contributing to the advancement of cutting edge technologies in the field. Ma'am, would you like to give any opening remarks to the participants?
Yes, Siddesh. First of all, good afternoon to one and all. So this is a very good platform that on this 19th international conferences, we have get a good opportunity to share our innovative ideas. So with this, just I would like to say that this platform is yours to you share more and more knowledge and gain more knowledge, because we should be always in the phase of a learner. So with this note, I would like to say thank you to entire team and best wishes to all the participants to present their paper. Thank you, Sadesh.
Thank you, ma'am. Now I would like to start with the papers. Our first presentation is presented by Mr. Shaharir Rahman. He is presenting the paper title, A Deep Learning Approach for Indoor Plant Health Monitoring Classification of Healthy, Unhealthy, and Dead Plants. Sir, are you there?
Yes, I'm here. So, am I to open my camera?
Yeah, sir. Yeah, you're free to open your camera. Just a second. Yeah, now you can share your screen also.
Okay, okay. My screen is visible.
Yes, sir, your screen is visible.
Okay. Good afternoon, everyone.
Sir, just a minute. Can you please start the slideshow?
Okay, okay.
Okay, sir, thank you. You can continue.
Good afternoon, everyone. I'm Sharia Rahman. So delighted to present our paper titled Deep Learning Approach for Indoor Plant Health Monitoring Classifications of Healthy, Unhealthy, and Dead Plants at the ICTIS conference in Thailand. So we are so appreciate to present our um, present our model and present our presentations to this platform. Uh, this is the sequence of our presentation. So we would like to just go through this. And we would like to start with our introduction part. So indoor plants are more than just decorative elements. They are vital in enhancing indoor air quality, boosting aesthetics, and supporting mental well-being. However, maintaining plant health can be challenging due to factors such as improper lighting, inconsistent watering, and environmental stress. These can lead to various issues like wilting, yellowing, or even the death of plants. So, in this study, we aim to develop a smart system capable of monitoring plant health and providing early detections of these issues. So we created a custom dataset consisting of 112, 1,200 images of our common indoor plant species and trained deep learning models such as Yellow version 8, Yellow version 9, and Yellow version 11 to classify plant health as healthy, unhealthy, or dead. So additionally, we explored the use of TensorFlow Lite to evaluate real-time performance on mobile device, providing a potential solution for mobile or edge-based plant health monitoring. So in these following scenarios, I will walk you through the methodology, results, significance of our work. So let's now go over the objectives of our study. First, our primary goal was to develop a deep learning based system to monitor indoor plant health, which can classify plant into three categories. So healthy, unhealthy, and dead plants. So this classification is crucial for early detections of plant health issues, enabling timely interventions to prevent further damage. Second, we built a custom dataset consisting of 1,200 labeled images of commonly found indoor plants such as the money plant, snake plant, bamboo plant, or under varying health conditions. So this dataset serves as the foundations for training and evaluating our models. Third, we explored the potential scalability of our model for broader applications such as in smart agriculture, greenhouse automations, and sustainable plant care systems. By ensuring that the system is scalable, so we aim to make plant health monitoring more accessible and impactful on a large scale. Lastly, we tested the real-time feasibility of our system by implementing a lightweight version using TensorFlow. So this approach was essential for evaluating whether the model would run efficiently on mobile and each device. So which would allow for real-time plant health monitoring in practical real-world scenarios. So now let's dive into the dataset collection and pre-processing steps. So for this study, we focused on our commonly found indoor plant species, money plant, snake plant, bamboo plant, spider plant. So these plants were selected because they are not only widely present in indoor environments, but also very in susceptibility to environmental factors that can impact their health. In terms of pre-processing, we followed several key steps to ensure the dataset was ready for model training. So all image were resized to a consistent 640 pixels to standardize input for the models. So pixel values were scaled to a range between 0 and 1 to help the model train more efficiently. So level encoding, like to classify health, we assumed levels 0 for healthy, 1 for unhealthy, and 2 for dead plants. So these labels were crucial for training the model to make accurate predictions. Finally, we split the dataset into three sets. So 80% of the image, so we use almost 960 images for training, and 10%, and which is like 120 images for training, for validation, and remaining it's for we have used for testing purpose. And this is the proposed approach. And in this slide, we will outline the experimental process for our proposed approach, who is focusing on mainly YOLO version. So as our pretend model for plant health classification, the process begins with a dataset which contains image of indoor plants, then moves to normalizations. So here the pixel values of the image are scaled to range of 0 to 1, so helping the model process them effectively. So after normalizations, we perform data split, dividing the dataset into three parts: 80% for training, 10% for validation, and 10% for testing. So this allows us to train the model, validate it for fine tuning, and assess its performance on unseen data. Uh, Here is the evaluations and training results. So in this slide, we highlight the key steps in training and evaluations, evaluating our models. For training, we used three pretend model, and the training process involves setting up the environment, configuring the model, and training using a data set of uh, 1,200 indoor plant images. So we trained the models for 50 epochs with images resized to its 640 and 640 pixels. So we, after our evaluation results finds that YOLO version 8 achieves 94.2% accuracy, while YOLO version 9 improved 95%, 95.5% accuracy. So while YOLO version 11 performed the best results, which is 96.8% accuracy, showing the highest precision, recall, and F1 score. So we also evaluate TensorFlow Lite for real-time mobile deployment. So while it achieved 91.0% accuracy with an F1 score 88.1%. So it offers faster inference and is well suited for edge devices. So in summary, YOLO version 11 provided the best performance, and TensorFlow Lite shows promising real-time capabilities for mobile and edge device applications. So that's all from our side. So thank you so much.
Ma'am,
So
would you like to ask any questions to the participant?
yeah, sure, it's okay.
Yes, shall I ask?
Yes, ma'am, you can.
I'm having one question. Can we use a generative AI technique for doing health monitor of the plants? Have you think about that?
Um, I think we cannot just use AI because this is not in our this is not including in our system actually.
Okay, there is one more question.
Okay,
Can we
okay.
do certain kind of reasons that why you are putting that plant as a healthy dead? So is there any kind of a reasons will be for that?
Yeah, because sometimes in indoor plants we
No,
don't know.
after yes, there will be a some sort of a reason, but to the
Yes.
end user, you are presenting that due to this reason. This is a called as a dead plant as a
Um.
summary line.
Yes, dead plants. So what was your questions
I am
actually?
asking about that you are giving summary to your users that these are the reasons due to which the plant is classified as a dead or unhealthy or healthy.
Yes, yes. It's mm, it's dead plants. It's
Okay,
dead
fine.
plants.
Thank you.
Okay.
Yes, just a quick question. Uh,
Yeah, sure.
uh, it is more related with technical things. Uh, how many training or balancing of the data you have done while training your model? Have you used the balance data set or it is imbalanced data set?
It actually imbalanced data set because it's little bit complicated complicated approach to find the indoor plants. So we approximately used mostly healthy plants because mostly dead plants and unhealthy it's not much available. So that's so we just focus on healthy plants, but we also used unhealthy and dead plants. So that's why which is why it's not biased to that plants.
Okay.
So
And one more thing, are you highlighting for example, you are following the three categories. If the
yes,
plant is in intermediate state, when it is not dead, but it is towards unhealthy position.
yeah, yeah,
So
yeah.
are you highlighting the areas where it is showing unhealthy behavior?
We don't highlight the specific area, but we just our model just can predict how about these conditions right now of that plants. I mean the current situations.
So for in future you can do that also.
Yes, yes.
Because
In future we have
that
yeah,
will
yeah.
bring more understanding to the classification which you are presenting, as well
Yes,
as
yes.
ma'am
Mhm.
stated that you should specify the reason of becoming the plant unhealthy, maybe due to over watering or less watering, too much
Yeah.
sunlight. This could be some of the reasons. Maybe some other reasons are also there. You can also specify those reasons why the leaves are turned into yellow or something like.
Mhm.
You may consult some expert in this area so that you can make it like a complete software.
Yeah, that's we have a plan for that.
Okay, all the best.
Thank you so much.
Thank you so much, ma'am. Thank you so much, sir. Up next, we have Ayan Banerjee. He is presenting the paper title Cellular Automata-Based Network Communication System Using Linear Rules for Resource Allocation, an Intelligent Approach. Ayan, sir, are you there?
Hello, sir. I'm audible.
Okay, sir. Okay,
Am I
sir.
audible?
You can, yeah, sir, you are audible.
I'm sharing my screen.
Yeah, sir, you can.
My screen is visible.
Yes, sir, it's visible. You can start.
Oh, thank you. Hello, everyone. I'm going to present my papers, Cellular Automata-Based Network Communication System using linear rules for resource allocation and intelligent approach. Our agenda is as follows: aim, introduction, past research, proposed work, experimental results, conclusion, and references. We are trying to develop a linear network communication system using cellular automata. We have calculated data communication time and data transmission speed using different data sizes. We have analyzed resource efficiency and system efficiency based on user requirement and predefined resources. In introduction, we are going to discuss like inter-cloud communication, cloud information interchange using various layers, application layer, virtual resource layer, physical resource layer, and cloud-based resource allocation. Some more aspects are there: client-server communication and resource indexing within network. In past research, we have studied the architecture of cloud computing along with the scalability and flexibility of cloud services. Some more past researchers are there: network virtualization and cloud-based simulation and different types of rendering. we are going to discuss our proposed one. We have presented the structural design of proposed framework using two gateways, user communication gateway and information interchange gateway. Through user communication gateway, user can interact with proposed controller. And information information interchange gateway, controller can interact with cloud environment for information interchange. Single attractor cellular automata based diagram we have presented here. Left one is for efficient resource identification, and second one is to allocate the efficient resource to user based on user analysis. This is our proposed algorithm. These are our inputs and desired outputs presented here. In step one, we are identifying the resource, identifying the network resources. In step two, we have collected information from network. In step three, we have categorized the resources, and in step four, we have produced a health analysis, CA-based health analysis to identify efficient resources. In step 5, user authentication has been done. In step 6, based on user authentication status, we have collected the user requirements, and based on user requirements, we have fixed one eligible resource to user in further steps. In experimental results, we have presented a time analysis based on number of users. In this experimental results, we have presented the data communication time and data transmission speed based on different sizes of data sets. In this graph, we have presented the ratio. We have presented the ratio between resource size and resource efficiency factor. We have presented a system efficiency factor in this graph. This is a comparison chart between existing system and proposed system. We have concluded several things like linear time complexity, category-wise resource efficiency, system efficiency, data communication time, data transmission speed, and a higher performance based on intense comparison between existing system and proposed system. The references are as follows. Some more references. Thank you.
Ayan, can you hear me?
Yes, ma'am.
Yeah. The question is, how can cellular automata be used to model dynamic behavior of a network traffic, or maybe for resources demands?
Actually, ma'am, we have tried to design a linear model for identifying network resources within our within network, and fetch that network resources like CPU usage, memory usage collected into our proposed controller and analyze based on user requirement.
Okay.
This way we are doing this. We have done this.
Okay. So dynamic behavior of network traffic will not be taken care.
Dynamic behavior we have not taken care. We will use it further.
Okay. Thank you.
Thank you.
Can you state how you have defined the maximum limit of users that you will stop by 400?
Yes.
Have you gone through some literature, or you have
Yes.
randomly
I have no. I have used some literature review on maximum number of users. They have used some 200 and 400. Like this figure I have found from literature review.
So why not they are showing more than 400? Have they specified some reason?
Actually, some experimental results, they have used some sample study like this.
So maybe by 500 you may get some other results. Have you tried that?
Yes, yes, I have tried some experimental results like based on this user count, but I
Okay.
have not used more than this.
So what is actually the difference which you have found? Any one of the difference if you found,
Difference means I'm not getting that
like ha- just show me the chart you have prepared.
one.
That peak chart. So here you see the time complexity, which has been increased by 400. So it will be increasing for more users also. Is there any
Yes.
time where it becomes constant rather than increasing in the peak form?
No one.
No? Thank you.
Okay.
Thank you, sir. You can stop your presentation.
Everyone. Our research paper is titled as Comparative Analysis of QLSTM and LSTM Models. The presenters are me, myself, Niranjan Shrestha, Sarat Kumar Khimire, and we are from Pulsar Campus, Institute of Engineering, Tribhuvan University, Nepal. Here are the brief contents that I would like to describe throughout this presentation, starting from the introduction with problem statement and so on to the future work and references. Starting with the introduction, machine learning has been explored the interplay of ideas from the combination of quantum computing and machine learning. Those technologies has been integrated collaboratively to form different quantum machine learning algorithms. However, this study delves into enhancing various types of data, mainly on the sequence prediction and data analysis through a comparative investigation on QLSTM and LSTM model for different factors and on the basis of different parameters. And the quantum LSTM will be validated on the real data that we will see through in this presentation as well, and exploring the quantum hardware limitation and various performance advantages over classical LSTM or classical machine learning method. The problem statement is that the traditional models like LSTM were struggling to fully capture patterns and dependencies on various types of data, and there has not been any proper comparative research on the classical LSTM and the quantum LSTM model specific on the stock market data. So the objective of our research paper is that to compare the working mechanism of the quantum LSTM and classical LSTM models in sequence prediction and data analysis, and to evaluate the computational efficiency of the quantum LSTM models comparing with the classical LSTM models, and also its performance and computational resources requirements as well. So here are the brief research papers that I have taken in this presentation for the literature review part. In these research papers, mostly they have experimented on applying or implementing the quantum machine learning approaches by using the classical machine learning and the artificial intelligence combinedly and collaboratively. Also, they have used various types of classical machine learning algorithms like RNN, CNN, and in different domains like natural language processing, time series, and also the computer vision. So they have presented various research data and comparison between the classical and the quantum machine learning algorithms. And also they have experimented on the quantum machine in real hardware as well, as it is suffering from the noisy intermediate scale quantum part. So they have made an approach to the real quantum hardware as well, using the different data sets and the algorithms. Mainly, this research paper has prepared a comparison between the quantum long short-term memory and the classical LSTM in the time series forecasting data, mainly in the solar power domain. So in this research paper, QLSTM has outperformed the LSTM on the basis of various factors, metrics, and the accuracy as well. So in this, the proposed methodology, we had started from the data acquisition part, taking the stock market data for the Merck and Co. Inc. That was scrapped from the GitHub, and the Prime Commercial Bank Limited stock data set that was the part of the banking domain in Nepal, and it was scrapped from the Kaggle. Similarly, those data set were pre-processed to form a perfect data to be ingested into the different models, that is LSTM and QLSTM. The model architecture formulation is the crucial part that I will briefly describe on the upcoming slides. And then we did some model optimization and training, and the performance were evaluated through root mean square error and mean square error metrics, and the results were analyzed and interpreted with using various graphs. In the model architecture formulation, as we can see, classical machine learning algorithm uses a simple approach that we can see it has only one layer. We can directly apply classical data into the machine learning algorithm. However, in quantum machine learning, we need different layers that need to be attached there. There is the input, encoding, and the readout part, where the classical data should be converted into the quantum data with application of methods like superposition and entanglement, and it should be processed and it needs to be converted back to the classical one. So it deep dives into the encoding part. And also, by applying these features like quantum gates, variational quantum circuit, quantum nodes, feature extractor, we can apply or convert the classical LSTM into the quantum LSTM part. As you can see in those gates like for gate, input, update, and output gate, variational quantum circuit is applied to convert the classical data into the quantum data through the application of entanglement and various rotational layers. However, it needs to be converted back, so the linear layer is attached for the classical post-processing part. In the result and analysis and interpretation part, as I have mentioned that we had two types of data set. One is the Merck and Cohen stock data set, and it is evaluated through the mean square error matrix. As you can see, the convergence is quite high in QLSTM, and it is fast that it converts into a lower accuracy than that of LSTM. Same as goes for the train loss and the test loss as well. And we can see that there is the consistency of achieving the lower loss in both of those models. Similarly, we can see the results in the root mean square error matrix as well. But for the Prime Commercial Bank Limited stock data set, we can see like in the trend loss, the convergence is little faster. But however, after two epochs, the loss has been comparatively a little bit greater than the classical LSTM. And also in the test loss, the loss has been a little bit greater after the sixth epoch as well, comparing the QLSTM and LSTM. And same goes for the root mean square error also. As you can see, this is the prediction graph for the MRK data set stock market. In this, the blue line represents the real stock market trend, whereas the orange represents the classical LSTM and the green represents the QLSTM. And as you can see in the test set part, the QLSTM has a little bit higher accuracy than that of the LSTM. And for the Prime Commercial Bank Limited data set, we can see that the LSTM, QLSTM, and the real market stock trend are linear to each other. They haven't diverged, so the prediction are much more accurate. So in the conclusion part, we found out that the QLSTM models showed faster learning and better convergence during the training and needed the fewer epochs due to its efficient architectures with efficient parameters and memory usage. And also it achieved the lower training losses with fewer resources. And but during And also during the validation, QLSTM performed the LSTM, indicating better generalization and robustness and also the QLSTM demonstrated an advantages in the prediction and the computational complexity compared to the classical LSTM. But however, there are some limitations to the QLSTM, as there are computational challenges in the existing quantum hardware. As we were using the quantum simulation, there weren't a little computational overhead. However, in those research paper, they had mentioned that there is the limitation in the computational overhead, as well as there is the quantum hardware limitation, and also the quantum approach hasn't been used for the broader data set or the across domains, and it has been a limitation as well. And also the classical architectures can be easily scalable and optimized, but in quantum it is little bit difficult. And for the future work,
So
it
sorry
is
to
that
interrupt. Your 9 minutes are over, so kindly wrap up your presentation.
okay, thank you. So these are the future works that I have mentioned. Like the most of the work should be done in the like quantum classical hybrid approaches, and similarly with that approach, the scalability and application would be much more reliable and efficient. These are the references that I have taken into this preparing of the research paper. Thank you. Any queries?
Should I ask?
Yes, ma'am.
Can you show me the charts which you have received? Well, so
Yes, ma'am.
yes, there are certain peaks there. The earlier
Right.
chart, yes.
Yes.
What could be the reason? The earlier one before this chart, yeah, this.
Uh, right, ma'am. Maybe the reason are like the data set is not like processed like MRK in code data set, as it is already standardized and was in the GitHub. So it was converging, like the models were accurately predicting, and there wasn't many much mic on that. I think the case was from the data set itself.
And will are you planning to take some real-time data set?
Well, we haven't figured out, but in the near future, we will take the real-time dataset.
Actually, after taking the real-time data set, then only you'll realize how different it is performing. Because in
Yeah, ma'am.
standardized data, there are so many pre-processings and all have been done. Na? So
Right.
you cannot state how model is performing. So in
Uh,
such conditions, specifically in case of QLSTM, it is
yes, ma'am.
must be real time so that we can know the performance of the model.
Yes, ma'am. Okay.
That's all from my side. Otherwise, the presentation is very good.
Thank you, ma'am. Thank you so much, ma'am.
Okay. So next presentation is presented by Karan Yadav. He's presenting the paper title Fake News Detection in Bengali Using Hybrid Summarization and Transformer Based Embeddings. Karan sir, are you there? Okay, sir. Uh, you can share your screen just a second. Yes, sir. Now you can share your screen.
My topic is on fake news detection in Bengali language using hybrid summarization and transformer based embeddings. And I am from NIT Hamirpur, India. Okay, so my uh, continuing my presentation. So the introduction part is digital platforms have transformed. We share information while they offer rapid and global updates. This platforms, online platforms, are beneficial for rapid updates and global reach, but there are also drawbacks for fake news spread, false or misleading information presented as factual. So, low resource languages like Hindi, Bengali, Tamil have scarce level data set. That's and Bengali language is the seventh most spoken language, but lack of sufficient research in fake news detection. So therefore, I researched in Bengali language. So the related works in Bengali in fake news detection in Bengali language have early approaches used as knife ways, decision trees, and SVMs faced challenges due to linguistic complexities, and the deep learning methods are used CNNs, LSTMs, and GRUs achieved better accuracy compared to traditional methods, and transformer based models are like Banglabird has been used for improved classifications. So the challenges I have faced in this research is the fake news data sets are often skewed with more authentic news than fake news. So the model performance bias model tends to achieve higher accuracy for authentic news, but struggle with the fake news classification. Because of date class imbalance issues, I have proposed the approach to applying hybrid summarization techniques to balance the dataset and utilize a combined Banglabird and Ambert model for better features extraction. So the proposed methodology part is I've used a data set called Ban Fake News 2.0, which is published 2000 in 2024, and it is available on Kaggle, which is publicly accessible. So this data set contains 47,000 authentic articles and 37,000 fake articles. And these are 13 different news categories: politics, sports, crimes, entertainment, etc. For hybrid summarizations, we have used for extractive method is Jake, and for abstractive method is MT5. So this is a model for hybrid summarization. Uh, so the train split of the dataset, we extracted all fake articles and applied GAIC and MT5 for extractive and abstractive summaries, and combined them, summarized and make a summarized article, and re added it back as a new fake articles to balance the whole training set. This is a proper workflow. First of this, the data set is splitted in training and testing set, and then the training set splitted in training and validation sets, and then applied hybrid summarization process for data set balancing, and then both models, Banglabird and Ambert, is used for feature extractions of this text articles. After the feature extraction of Banglabird and Ambert, it is concatenated. Both are concatenated, and then further proceed to the fully connected layers, and then classified as a real and fake. So as we move on for the results, by applying hybrid summarizations and then use the models like BERT, Uncache, and DistilBERT plus combination of DistilBERT and multi-head attention, and BanglaBERT and MBERT, and the final is Bangla plus MBERT. So these are the results. Best results we are found in Banglabird plus MBERT model, which we have discussed in the previous slide. These are the comparison with the previous work. Our model is our model is surpassed all the previous works as the results. As you can see, authentic and fake articles classification are both results is as good, but in previous researches, these were the only authentic articles classification is good or not the fake as well. So the conclusion is we find key findings is there. We're addressing the class imbalance using hybrid summarization. It uses the Banglabird and MBERT for better feature representation, and our model is outperforming baselines on ban fake news and ban fake news 2.0 data sets. So the future works is expanding data set and apply the methods to other low resource languages and explore generative adversarial networks for the data augmentation to generate high quality synthetic fake news samples and further address class imbalance. These are the references. Thank you. Hello. Hello.
Karan, are you able to hear me?
Yes, ma'am. Yes, ma'am.
I'm not able to understand what newness you have added in your model. How it is different from Bangla BERT model?
Bangalore.
Yes, how it is different from what newness you have
Okay.
added in you?
So
Bring the model diagram. So
okay.
you,
So okay. Hmm. So,
yes.
ma'am, earlier, have to previous slide. So the ma'am, the hybrid summarization, we have used a hybrid summarization method for oversampling, for which is not ever used before. This for because of this, the fake articles were represented feature extractions is in better qualities in by using the hybrid summarization as a oversampling methods. That's why it is performing on good in fake articles also. The previous works is on so it faced issues on because of class imbalance because of the articles.
So basically you have worked on pre-processing stage where you are making the more refined data.
Okay, ma'am. Yes, ma'am.
Not on the model, you have not done on any
Model. Yes,
on the
ma'am.
model,
The model
which
after
you
the
are already using the previous model only, but you have worked
no,
on
ma'am.
pre-processing.
I have worked on pre-processed and then I have used
Combine two models.
yes, ma'am. Yes, ma'am. Bangalabert and Ambert combining these two models.
So
And
how did you get this idea
because
that
of
you
my
should combine these two kinds of model, as well as how
ma'am,
yes.
Bangalabert is well fine-tuned for Bangla language, and the Ambert model is a multilingual bird model. So it is also fine-tuned on multiple languages, which is low resource languages. That's why I have used this both models.
So whether your model will be able to determine the language which has mixed text, like in a Bangla we are also using some English text, it will be able to identify it.
Yes, ma'am. No, that's why we have used Mbert also. Bangalabert can also identify that words, but feature representation is that's why Bangalabert and Mbert combination is working good rather than separate a single model using.
And sometimes there are some emotions also in the content which are in context of word it is positive, but otherwise it is a negative.
Yes,
Whether
ma'am.
these models be able to determine that also?
Ma'am, in this data set, there are some kinds of news like that, but I don't specifically
like
know.
for example, whether XYZ will win the election or not, like this, or have they attained certain score or not, scores and question mark, like this. The question format news are there.
Yes,
So
ma'am.
are these
So
model catering that conditions?
ma'am, the model is the training set we are using is different online resources, language, online news resources. In that news, there's a labeled data set which is labeling as
Already
yes,
fake
ma'am.
or okay, you are
Yes,
already using the
labeled
standard data
yes, ma'am.
set, and then you, so
Yes.
maybe in future you will be able to experiment on such kind of things all as well?
Yes, ma'am. Yes, ma'am. I'm in future work. I also working on the image parts also. Which
Okay.
yes, ma'am.
So all the best from my side.
Okay, Karan, can you hear me?
Yes, ma'am.
Is there model is have you checked it for that false positive and false negative performance parameter?
Yes, ma'am. So the results is a precision, recall, and F1 scores. Yeah, these are the false negative and false positive. These are the classifications scores. It comes from true negative and false positive.
Okay, so for complex news, just like ma'am says, there will be a English words or emotions. So
Yes,
have
ma'am.
you evaluated your model that it will reduce that false positive or negative, and it will be able to get complex news or some kind of a hybrid news?
Okay, man. For like there's articles which also have English words. So that's why we have used Embert model also. Embert model is trained fine tuned on all languages like English, Tamil, Telugu, and all low resources language. So the linguistic part is captured in the Embert model. So it can be classified as well.
Okay, thank you.
Okay. Uh,
Thank you, Karan. You can stop your presentation.
okay. Thank you. Thank you, everyone.
Up next, we have Saram KP. He is presenting the paper title FPGA-based Smart Temperature Regulation System for Enhanced Patient Care. Saram, you
Hello,
can start with your presentation.
am I audible?
Yes, yes, you are audible.
I have sent a request for sharing this screen. Okay,
Now you try once again. Now you can share
okay,
your
I got it.
screen.
Is it visible?
Yeah, it's visible. You can start.
Okay, good afternoon, everyone. I am Sarang, and I am honored to present our work titled FPGA-based Smart Temperature Regulation System for Enhanced Patient Care on behalf of my co-authors, Ajay Narayan, Vishwajit K, Nagarajan PM, and Rami Ajay. So a little bit about myself. I am a student at Amrita Vishwavidyapeetham at Amrapuri. I am pursuing a degree in electronics and computer engineering. So temperature and environmental conditions are probably the last thing on your mind when you are in a hospital. You're likely more concerned about your doctor, the treatment, or the surgery you are about to undergo. However, temperature plays a crucial role in affecting your health and recovery. Research has shown that ambient temperature can influence a patient's heart rate, breathing, and overall comfort. Too cold, and it may cause hypothermia or discomfort. Too warm, and it can contribute to dehydration or bacterial growth. Yet, hospitals often rely on centralized temperature control systems that lack adaptability to individual patient needs. This is where our research comes in. So, I'm going to be talking about the importance of temperature regulation. This project aims to enhance patient care through smart FPGA-based temperature regulation. Unlike traditional systems, FPGAs enable real-time patient-specific monitoring and adaptive control, essential in healthcare environments. General hospital air conditioning lacks personalized temperature management, which can impact recovery, increase infection risk, and reduce comfort. Our system addresses this by ensuring optimal conditions tailored to each patient's need. Temperature control is especially critical in neonatal units for burn victims and post-surgical patients, where precise regulation can prevent serious complication. Now on to the literature review. Existing research include a study from GV Press on temperature and humidity monitoring in key hospital areas. It highlights how environmental factors like temperature significantly impacts patient well-being. Hospitals are recommended to maintain room temperatures between 21 to 24 degrees Celsius to ensure patient comfort and prevent risks such as hypothermia or overheating. This range is particularly important for vulnerable patients, where even slight fluctuations can impact recovery. FPGA technology has gained attention for real-time applications due to parallel processing capability, lower power consumption, and flexibility. Unlike microcontrollers or standard processors, FPGA can handle multiple sensor inputs and execute decisions instantly. This makes them ideal for applications where rapid response and real-time adaptations are required, such as patient care environments. Moreover, traditional microcontroller-based systems may face limitations in scalability and processing speed. The FPGA's ability to implement custom logic for real-time analysis gives it a distinct advantage in medical applications. It ensures that temperature adjustments occur without delays, preventing extreme fluctuations that could affect the patient's well-being. Now on to the objective and the methodology. Our research focuses on designing a smart temperature regulation system that uses FPGA to monitor environmental conditions in real time and dynamically adjust temperature settings. The key objectives of this research are to develop a real-time monitoring system that continuously tracks room temperature, utilize FPGA for high-speed processing and decision-making, enable wireless communication for remote access and control, ensure adaptive temperature control based on patient's conditions. For this, we have used a combination of hardware sensors, FPGA processing, and wireless control mechanism. This methodology involves sensor readings being fed into the FPGA. The FPGA processes the data, detects variation, and triggers adjustments in the temperature control system, as in the AC units. The decision-making logic is designed using Verilog and optimized for efficient energy use. The proposed system. As you can see from the block diagram, our proposed system consists of a combination of sensors placed around a patient's bed or hospital room. These sensors feed real-time data to an FPGA-based processor, which evaluates the readings and sends control signals to an IR-based temperature control unit. This unit can communicate wirelessly with air conditioning or heating devices to adjust the temperature accordingly. The introduction of wireless communication reduces the need for extensive wiring, making installation easier and improving system flexibility. Additionally, the system can be integrated with hospital management software, allowing doctors and nurses to monitor room conditions remotely. This system eliminates the delays of manual temperature control, ensures accuracy, and enables customized patient care rather than a one-size-fits-all approach. Onto the hardware overview. To achieve precise monitoring, we incorporated the following hardware components. DHT11 sensor. This sensor measures room temperature and humidity and feeds the data into the FPGA for processing. It provides a basic, reliable measure of environmental conditions. MLX90630 sensor, an infrared temperature sensor capable of detecting patient body temperature without physical contact, crucial for ensuring comfort and medical safety. This is particularly useful in isolation wards, where minimizing physical interaction is essential. An IR transmitter module. This module sends control signals wirelessly to adjust the data conditioning system based on real-time data, reducing dependency on manual adjustments. To maintain clarity and scalability in design, we created separate Verilog modules for each sensor and developed the system using Vivado on the Arctic 7 FPGA board, enabling accurate real-time data acquisition and control. These sensors work together to provide an accurate environmental profile, allowing for intelligent and automated temperature control. On to the system implementation and simulation. This entire system is implemented using Verilog HDL, which runs on an FPGA platform. We developed a custom temperature regulation algorithm that processes real-time data from the sensors and adjusts room temperature accordingly. The project flow includes sensors, bitstream generation, and pin mapping via an XDC file. The key implementations are the modular design. Each functional block, including sensing, control, and communication, was created as an individual Verilog module, enabling clarity and reusability and scalability. Corresponding test benches were written for each module to simulate and validate functionality before deployment. Temperature sensing, the DH11 and MLX sensors were interfaced using Verilog. Timing requirements were carefully handled through dedicated modules and validated with test benches, ensuring accurate and consistent temperature data extraction. The control logic, based on the sensed body temperature, the system recommends room adjustments differentiating between fever and hypothermia and normal ranges to optimize comfort. The control level was synthesized and integrated as part of the overall design. Wireless communication. An IR transmitter module was integrated into the system for wireless control. The logic was implemented in Verilog and signal modulation was tested using simulation tools before bitstream generation and deployment. This FPGA-based approach offers efficient operation, energy saving, and room for future enhancements like perhaps ML-based predictive control and IoT connectivity. I would like to conclude by saying that, in conclusion, our FPGA-based smart regulation system is a significant step towards enhancing patient care through real-time environmental control. By integrating speed processing, wireless communication, and adaptive temperature management, the system offers several advantages, such as optimal environment. It enables continuous and accurate monitoring of both body and the room temperature to maintain ideal conditions for the patient recovery. It is capable of handling multiple sensors inputs simultaneously, allowing for real-time environmental adjustments based on the patient's need. And future improvements offer scopes for integrating advanced health monitoring features, IoT connectivity, and machine learning for predictive analysis and remote patient management. In future work, we aim to integrate machine learning modules to predict temperature changes based on the patient vital signs. With continuous development, our system has the potential to revolutionize hospital environments, ensuring every patient receives optimal care tailored to their needs. Thank you. That's all for the Q&A sessions. I'm audible.
Yes, Sarang, you are audible.
Uh,
Ma'am, do you have any questions?
Okay, how you will integrate this system in real-time healthcare system? Hello,
yes.
how you will do the integration?
This system is fully automated. We can implement this the device. It's like similar to a device. We'll implement this in the hospital room, and it will take the connection from the AC, and it is all wireless. And so it will be able to it will check the body temperature and the room temperature, and as per the Verilog algorithm, it will adjust the room temperature accordingly.
Okay, means have you done the real-time testing for this?
We have not done it in a hostile environment, but we have done it in a normal setting.
Okay. So have you checked the energy efficiency in this case?
Energy efficiency.
Okay, fine. Thank you.
Thank you.
Just a quick question. What
Yes, ma'am.
about the constraints? Are there any constraints of your system?
Constraints.
Yeah, limitations or while implementation challenges or requirements.
Challenges include
See, at present you have not implemented it anywhere, but in future, if you're going to implement in a hospital environment, what challenges or necessary requirement you're going to see while implementing this kind of system?
The challenges can include like the timing constraints, uh, whether the sensors, how accurate the sensors are. It all depends on the accuracy of the sensors and the boards which are available. Since in this demonstration, we have used an RTX 7 board, but uh, the timing constraints, we might need to change.
Maybe you can think over it and include in your further research.
Yes, ma'am.
All the best.
All right, ma'am.
Thank you, Sarang sir. And ma'am, you can stop your presentation, sir. Yeah, thank you. Up next, we have Sayanthika KR. She is presenting the paper From Pixels to Stories, a scalable AI framework for dynamic image narratives using Vision Transformer and GPT-2. Sayanthika ma'am, are you there?
Yes, sir.
Okay, ma'am, you can start your presentation.
Good afternoon, everyone. I am Sayantika from Amrita School of Computing, Amrita Vishwavidyapita. So today I am here to present our research title, From Pixel to Stories, a scalable AI framework for dynamic image narratives using Vision Transformer and GPT-2 model. Our paper ID is 531. So this work focuses on generating structured and meaningful narrative from image using an AI-driven techniques. In traditional image captioning techniques, it lacks a context and depth. So our objective is to bridge the gap between the vision and language, transforming static captions into a meaningful narratives. We propose an AI-driven framework that integrates Vision Transformer, GPT-2, and named entity recognition module along with the knowledge graph creation for a structure and dynamic stories from the images. Our problem statement and the research contribution includes and aims to generate a caption for a set of images and then create a cohesive story based on them. Our key contributions include developing a pipeline using Vision Transformer and GPT-2 to generate accurate captions and addressing object hallucination and semantic misalignment. Then we extract the entities and relationship from the captions generated to create a visually represented knowledge graph using the network X. And then we'll give that to a Cohere API that converts into a story. This establishes a flexible framework adaptable to various datasets and real-time applications. So coming to the background of the work, automated storytelling is evolving field in AI. It involves creating contextually rich and coherent narratives from visual data. Our approach leverages advanced AI techniques to improve the quality and the scalability of the multi-image storytelling. As you can see, in the traditional story creation method, it is very time-consuming and a long process. But in our approach, it is easier and quick enough to generate story even after the visualization of the entity and the relation by constructing a knowledge graph. So we have referred few of the papers and the research gaps that we identified is in such a way that in the first paper, like the beyond entities, a large-scale multi-model knowledge graph with triplet factor grounding, the research gap that we identified in this is a multi-model knowledge graph neglects visual grounding of the relation. And also there are data noise and dependency issue on the pre-trained models. So next, coming to the deep learning approaches on the image captioning or review, the gaps identified are object hallucination, and missing context when we are captioning the images. This creates a semantic misalignment and data set bias. Next, we have other two papers where the limitation is inaccuracy in identifying or detecting the object, and we have the relationship between each entity. Last one is the paper titled Architecture of the Knowledge Graph Construction Technique. This lacks clear documentation of the knowledge graph construction and to extract the entities from the resource. So the research gaps identified in this are existing captioning method primarily rely on direct visual features and struggle with missing relationship between each entities, semantic misalignments that lead to inaccurate date description, and inadequate entity extraction techniques. Our framework addresses these gaps by implementing an adaptive named entity recognition pipeline for improved entity and relationship extraction. And this enhances the image captioning accuracy with the Vision Transformer GPT-2 model and create a structured knowledge graph to establish a meaningful entity relation. So coming to the high level design of the proposed system, our workflow is we give multiple images to as an input to the Vision Transformer GPT-2 model, where each image is divided into fixed patches, which are then linearly given as a vector and with each positional embedding to retain the spatial relationship. These embeddings are passed through multiple layers in the Vision Transformer coder, where self-attention mechanism helps to extract meaningful representation. The processed features are then fed into the GPT-2 as a decoder. The GPT-2 model uses a masked self-attention to ensure the sequential word generation as an encoder-decoder attention mechanism to relate visual and textual output. Then we finally get a caption for the given images. And then these captions are then given to the NLTK module where we can get the entity and the relationship of each generated caption. And then we'll be giving that to the network X to create a knowledge graph for the visual representation. With the help of the knowledge graph, we'll be giving to the Cohere API to generate an engaging and narrative story. So coming to the methodology part, image captioning is the first module that we have integrated. So in this, the input will be the multiple images and the process we include our feature extraction using the Vision Transformer, and then the feature decoding will be given to the GPT-2 model. So as an output, we get a descriptive caption summarizing the content of the image. For example, if the image is a dog is running in a beach, the caption will be generated to the same content. And then the next module is entity recognition module, where captions are analyzed using NLTK module to identify people, objects, and location. Grammar-based techniques extract relationship between each entities. The output is identified entities and relation ready for the graph construction. Next is the knowledge graph construction module, where we create a knowledge graph from the captions that we got by identifying the entities and the relation between them. Then we have the story generation module, where we use the Cohere API to transform the knowledge graph into a structure and narrative story.
Sorry to interrupt you, ma'am. Your 9 minutes are over, so kindly wrap up your presentation.
So coming to the experimental setup, for evaluation, we have used Flickr AK dataset, which contain 8,000 plus images. The dataset allows us to integrate with the pipeline in a meaningful narrative. The testing was also done using the same dataset. And also we found out the accuracy and the F1 score of the generated captions. So coming to the results, as you can see, this is the user interface part where we have given multiple images, that is 5 images as a input. And then we have identified the entities and the relation, and the captions are also mentioned here. Then we have constructed the knowledge graph, and this is the story generated using the Cohere API. So in conclusion, our AI-driven framework enhances image-to-story process by integrating vision transformer, NLP technique, and the knowledge graph. It efficiently converts static images into meaningful and narrative part. This work has applications in journalism, storytelling, and creative content generation. The challenges that we faced in are scaling the system to large handle data set without compromising the efficiency, and improving in the domain-specific storytelling through fine-tuned models, enhancing the real-time adaptability for the dynamic applications. And these are the references that we have referred to. And that's from my side.
How can we handle the repetitive content generation?
So for that we have used the grammar in NLTK module, so that we'll be finding if there are same entities or the multiple entities are coming twice or thrice. So we'll make sure that it will be only seeing as one in the visual representation in the creation of the knowledge graph.
Okay.
For such models, do we have any matrices to evaluate? Like, for example, if you have generated the knowledge network, is there any parameter whether the network has been properly generated or not? And another thing is when it is generating the story, whether it has considered all the images or the characters taken in the images in the story. How will you check that? Is there any matrices to evaluate all these things?
Ma'am, for the for metrics kind of thing, we have looking on the caption generated caption. We'll be comparing we have compared the captions generated, like in the Flickr 8K dataset, there are captions for each images. So we have already found out the accuracy between the captions that we got from our model, and then with the already with all pre-saved captions. So the accuracy was quite good. And then about the metrics part, for the graph network thing, uh, so as I mentioned earlier, that we'll be using the NLTK module so that the repetition will not come. So that's the one method that we have used.
Maybe because there are many times it happens that we are providing certain images and it is using some like 5 images I'm supporting given to the system, and it is mostly utilizing the first three images, and for second two images it is using it as minimum level. So how we'll attain a balanced approach so that a balanced way the images are being used? So again, this is a question, maybe you must have not think over it. In future you may add such things as well.
Okay, ma'am.
All the best.
Thank you, ma'am.
Thank you, Santika ma'am. You can stop your presentation.
Thank you, sir.
Up next, we have Satyendra Yadav. He's presenting the paper titled LLM-based efficient framework for dense video captioning. Okay, sir, now you can
Yeah,
share
I'm
your screen.
Yep,
Yeah.
yep, sure.
Thank you, sir. You can start.
Yep, sure. Hope my screen is visible.
Yes, sir, it's visible. You can start.
Okay, thank you so much. Yep. So I'm Satyendra Yadav, and I, along with my co-author, Dr. Vidushi Sharma, are going to present this paper on LLM-based efficient framework for dense video captioning. I'm from Gautam Buddha University in Greater Noida, India. So I'll start with the basic introduction of the problem. We can see, nowadays, the video content are the major content in terms of media consumption across different platforms. So different platforms like YouTube, Instagram, TikTok, and other similar platforms, they are having a lot many video contents. There are many content creators who are creating those contents on regular basis. So with this rapid growth, we need to have some automated model which can process those videos and can generate the automated textual information from those videos that can be readily used by these platforms to enhance the overall overall the people's engagement. So while watching one YouTube video, you can scroll through the video, but if you want to know information what content that video contains, for that you need to process the video before presenting it to the outer world, and with that conversion you will be able to provide the textual description of the video, and user can directly search through that video. So if I am looking for conclusion section in a presentation, I'll be just typing a conclusion in the search box, and I'll be redirected to that particular segment in the video. So there are different challenges which exist in this particular domain. So it should be human alike, and it should be contextually accurate, and also it should be able to extract useful information from the videos, whatever the relevant information we have from the video. Sorry. Okay, so I'll start with the video captioning, which is the basic problem which we are covering here. So video captioning is nothing but it's like generating the text descriptions from the video content, and it will enhance the overall accessibility, searchability, and the user engagement. So with that textual information, as I already explained, we'll be able to provide different things to the users, right? Okay. So the video captioning is of two types. One is like the simple video captioning, wherein we generate the brief description of the video. And in case of dense video captioning, we have to provide the detailed, we have to do the detailed analysis, and then we divide that video into different segments and then try to understand the content of that video. And basis that, we try to provide the description of the various segments in that video. So dense dense video captioning is more complicated, it's more problematic, and it's like we'll face lot many challenges while going through that journey of doing the dense video captioning. So in this particular paper we have covered, we have done it for dense video captioning problem. So this is just one brief example on the dense video captioning, wherein you can see one person is playing a guitar, and then the crowd gathers and they enjoys the overall program which is happening on the streets. So here you can see like the first frame it identified like a man is playing the guitar in front of the crowd, and then in the second frame the second person also joins him, he starts singing with him. So these two frames for this blue part, this is overall one segment, and then again on this orange, this becomes the another segment. So we have two different captions for first two segments, and then the third segment comes wherein you can see it in the green lines. Here the crowd has gathered and they started listening to the music, and in the fourth frame you can see like the man is thanking to the person who was having that guitar, and finishes the show. So this is at a very high level the dense video captioning problem, and how what kind of captions we are going to provide and how we are going to segment it uh, to solve this problem. So for this specific problem, we picked with two sequence model. It is one of the state of art model which provides us the captioning of different segments of the video. So it is better in doing the simple video captioning, dense video captioning. Then it also works on the video QA thing, and also like in order to retrieve specific videos, it also helps. So like I mentioned about the that YouTube example wherein you can search directly for the specific segment in the video. So that kind of retrieval it can does. And it takes the input as the video frames, and then it analyzes those frames and process it, and then it generates output in the form of text sequence, or we can call them as captions or answers to those queries which are being posted on for that particular video. Okay, so using this with to sequence model, we are proposing this particular model, and it is basically three-step process wherein in first step we are going to do the encoding, and it consists of two encoders actually. One is the visual encoder and another one is the text encoder. So whatever visual contents are there in the video, that is being processed by the visual encoder, and all the textual contents are being processed by the text encoder. Secondly, we have the decoder, which combines the output from whatever it gets from the visual encoder and the text encoder, and then it processes it, generates the caption, accumulate all those captions, and then it transfers that output to the LLM model. So specifically for the LLM work, we have used the GPT-4 model here. So it takes the input from the caption accumulator, and then it processes that textual data, and then it generates the final output, final output in terms of the caption for the whole input sequence. This is the system architecture at a very high level again. So it basically consists of two parts. One is the encoder block, as I already mentioned, and second is the decoder block. So in encoder block, we have that visual and the text encoder. The visual inputs are provided to the visual encoder. All the text inputs are being provided to the text encoder. With the text, we also have the time tokens. So time tokens provide us the information like from which particular time this text, this audio sequence is getting started and when it is getting ended. So with that information, we are going to map it to the video content, so that whatever caption we are generating for the video content, it is going to match with the time token, and then accordingly it will process the visual and the audio content together. And then this output goes to the decoder block, which combines both the output from the visual and the text encoder, and it generates the caption for those specific video frames, and it accumulated in the caption, get accumulated in the caption accumulator, and then the GPT runs its magic. Then it provides the final output, and along with the timestamp of the video.
Sorry to interrupt, sir. Your 9 minutes are over, so
Oh.
kindly wrap your section.
Okay, sorry. Yeah. Okay, so this is again one of the example wherein Neeraj Chopra is in the Tokyo 2020 Olympics. He's going for that javelin throw. So we have the input speech, and then we have the video frames, and then the video with to sequence model. What it does is it analyzes both the input video frame and the audio frame, and then it generates the caption for each frame. And then the GPT-4 combines all those frames together, output for all those frames, and it generates the final output. So in conclusion, we propose this integration of the with to sequence and the GPT-4 model for dense video captioning, and then generated the final refined output. Like earlier with to sequence, whatever it was generating, it was not the final output, and it was more on the specific segments of the video. But with this integration, we are getting captions for the whole video sequence. And basis the findings from the with to sequence models performance, it outperforms a lot many models, and then GPT-4 enhances the contextual awareness on the language understanding. So in terms of future work, we are going to automate these two integrations, and then we are also going to use different LLMs so that we can be able to find which particular model is giving us the better results. And also, we are going to extend this model to long video understanding. Currently, we are restricting ourselves to these smaller videos, and later we are going to extend it to the longer videos. And these are the references. Thank you so much. Any questions?
How you ensure the captions are accurate?
Okay, so right now we are relying more on the human feedback. So whatever executions we are doing, we are reviewing them manually right now. But there are certain frameworks which we can integrate at a later stage. So that is in our roadmap. In future, we are going to include those things as well.
So you are checking time alignment with the specific actions?
Yes.
Okay,
So,
fine. Thank you,
yeah.
sir.
Yep, sure. Thank you.
About
Any
the
other?
hardware and software platform which you are using?
Sorry, ma'am. Can you please
What
come?
about the hardware and the software platform you are using for this?
Okay, so the whole model is Python based, and we are running it on the NVIDIA GPU. So yeah, that was again one of the constraints actually.
Because I was seeing that you have used two encoders, and then you are using such a complicated structure, and definitely
Correct.
require good hardware. Otherwise, the performance will not be attained.
Right. So initially we started with the that GPU in shared mode, wherein multiple people were using, and with that I think we were failing actually. It was not able to complete the execution. So then what we have done is we have taken one higher version of the GPU, and that again we were strictly prohibited the other uses, and so that we can have that results and the proper execution of the model.
Maybe you should have your dedicated GPUs.
Yeah, for video models, that is one of the problems. So, like for my future research work, I am moving back to the images actually. That runs on the.
Seek for some government funded projects so that you can at least cater the hardware requirements. Otherwise, the project will not work as you have planned.
Yep. Right.
All the best.
Yeah. Thank you so much, ma'am, for the feedback.
Thank you, Satendra sir. You can stop your screen sharing.
Yep, sure, Siddesh. Thank you.
Yeah, thank you. Up next, we have Shruti Sinha. She is presenting the paper title Explainable AI for Diabetic Retinopathy Detection. Shruti, are you there? Shruti, ma'am?
Yeah. Am I audible?
Yeah, you are audible. Just a second. Now you can share your screen.
Is my screen visible?
Yeah, it's visible. You can start.
Okay. Good afternoon, everyone. I'm Shruti Sinha, and I'm delighted to present our research paper conducted with Sanjeev Prasad Pandey, Aman Shakya, Basanta Joshi, and Anunay Pandey Our paper entitled Explainable AI for Diabetic Retinopathy Detection, we represent from Pulchok Campus, Institute of Engineering, Kathmandu, Nepal. Yeah, this is the overview of my presentation, which includes introduction, problem statement, literature review, proposed method, methodology, experiment and results, and references. Diabetic retinopathy, one of the most severe complications of diabetes. It occurs due to the damage of tiny blood vessels of retina, which leads to vision loss and blindness. With the rise of diabetes causes globally, diabetic retinopathy has become a major public health concern. As we can see from the image on the right side, we have the normal retina and how the image looks for the diabetic retinopathy disease. So the problem statement includes that its leading cause, we need an early detection of diabetic retinopathy system. Manual detection methods are slow, subjective, and inconsistent. There is a significant demand for the automated detection system. And basically, current system lacks in interpretability, limiting trust and clinical integration. This is the sum of the literature review which I have done from the past 3 years and find out what the problem has been done and there is a research gap that needs to be fulfilled for the further researchers. We propose to design a robust deep learning model to predict diabetic retinopathy and interpret the results using explainable AI technique. Moving on to the methodology part, this is the block diagram of our research work where we have the image data set taken from the Asian Pacific Ophthalmology Society, which is then used for the image processing task. Image pre-processing task, we have done the normalization and the image resizing. After that, the image data set has been used for the model training with the three different CNN architectures that are exception model, inception v3, and VGG16. And after doing the model training, we evaluated their performances. So we have not just evaluated this performance one split, but we have worked for the three different split for the comparison. We have also used the two different regularization technique for this work. And after that, we have found out the best one perform model was on the 80-20 split with the exception model. After that, we use that model for the prediction and the classification. And that prediction and classification was connected for the explainable AI GradCam for further interpretability, how the CNN clinical validation of the work were done. So this is the algorithm of our research work, how it basically works, as I have explained on the block diagram. So for this is the original data set, and after the augmentation, we have done the oversampling method for um, the augmentation. These are some of the experiment and analysis of our work. So for the early stopping technique for the exception, which shows us the accuracy and loss graph and the confusion matrix for the exception model. Further, we have done this for the inception V3 architecture, where we have the accuracy and loss curve and the confusion matrix. For the VGG16, accuracy and loss curve and the confusion matrix. So this is the comparison for the early stopping method on the three, which is 80-20, 70-30, and 60-40. And now another experiment was done for the L2 regularization technique. For the VGG16, we have accuracy and loss graph and confusion matrix. Same for the inception V3 after using the L2 regularization for the accuracy and loss graph and the confusion matrix. For the exception model, this is the confusion matrix for the exception model. So the best performed model was exception model, which I said prior on the 80-20 split. And this is the train and test split for that. This is the experiment and result of the comparison from this L2 regularization technique for the 80-20 split, 70-30 split, and the 60-40 split. So comes the visualization with the GradCam works for our model. We input the image, it passes through the CNN, then the activation map is formed. After that, we get the logit score from before passing it to the softmax function. Then that logit score derivative with the activation map is created, and then the global average pooling of the gradient maps are done. After that, the ReLU is applied, and then we get the GradCam heat map. So that last, what the result we get, it is superimposed on the original image and find out the how actually the model sees while predicting the classification. These are some of the experiment and results from our work, some of the tools and technology used. So at last, I would like to conclude it by saying in this study, we successfully implemented multi-class diabetic retinopathy with the integration of GradCam providing visual heat map explanation that improved model interpretability. Deep learning for this helps for enhancing the improving the detection accuracy and enhancing access to retinal image interpretation, and the comparative analysis for the three different architectures were done across three different splits and find out that exception model achieved the highest accuracy of 86 then with the L2 regularization on the 80-20 split. For the future enhancement, we have the data expansion, which we include acquire and integrate more diverse data set from the enhanced population to generalize across different patients, and more explainable AI technique like integrating LIME and SHAPE for the further. These are some of the references. Thank you. Any queries?
What are the limitations of your work?
Limitations. I think we need more data set for different population.
Okay. Is there anything else?
And more explainable AI technique to make it more reliable for real world.
Fine.
What kind of explanation it is giving to you?
It's explaining that how the actual model works, because for making it trustworthy for the doctors, they have to know which portion of our model sees while predicting the specific classification of the work.
So
So
how
that's
it is showing? That is my question. How it is showing it? Is it
by the
showing in
algorithm.
text format, or it
No,
is
it's showing
highlighting?
in the image form. Like I currently showed you in my slide,
Yes.
which showed
Yes.
it generated the heat map.
So the user has to understand the heat map. As a
Yeah,
doctor,
basically,
doctor has to understand the heat map.
it will give them more clear idea. Like doctors will see, okay, yes, just by giving a classification, it's a diabetic retinopathy or not a diabetic retinopathy, but giving it through explaining from the crack cam, it would help them.
I think it should be in more easier terms, na? Rather than depicting it just in a heat map format.
Um,
What do you think?
um,
Maybe in future you must add such things, because being an area expert, they'll prefer something which is more easy for them to understand rather than just depicting in chart format.
yeah, but heat map will also superimpose in the original image, so it will highlight the portion, right? Like, so yes.
Rather than highlighting the regions, instead of making a heat map, highlighting the regions, that these are the regions, will be more
So
easier for them to understand.
can I show you my slide again? Or
No, no, it's okay. It is just a suggestion for my side. You may
Thank you so
consider in future. Okay.
Yeah.
All the best.
Okay.
Thank you.
Okay. Thank you.
Thank you, Shruti ma'am. Moving forward, we have Han D. Nguyen, and he's presenting his paper titled The Success of Cloud-Based E-Learning System Evidence from Vietnam. Sir, are you there?
Yes.
Okay, you can proceed with the presentation.
Yeah, can you give me permission to share the screen? Okay.
Okay, so are you presenting on the behalf of him?
Yeah,
Correct?
that's right.
Okay, correct. Got it.
Okay. Can you see my screen, right?
Yeah, it's visible. You can start.
So, okay. Our page. Yeah, I will represent for Miss Tan, and our page title that is about the success of cloud-based e-learning system invited from Vietnam. Yeah. First of all, we have to go to introduction. Management information system helps transform administrative and education processes, enabling more effective decision making and directly improving the performance of academic institution and student learning outcomes. Right, or 2019. Cloud computing offers numerous advantages, such as increased storage capacity, resource sharing, support for flexible learning, and reduced infrastructure cost. By 2021, the e-learning market is projected to reach significant growth in the coming years of $141.2 billion with an anticipated annual growth rate of 15.5% from 2023 to 2032, according to Global Market Insight 2024. In addition, in the pandemic week of COVID-19, the percentage of educational institutions that transition to online or blended learning rose to 85% in 2021, up from 45% before the pandemic, according to World Economic Forum 2022. Cloud-based e-learning has materialized as a significant area of research due to its effectiveness and success, such as our 2021. Despite improvements in learning accessibility and interaction, challenges remain regarding system quality. A study found that only 62% of students expressed satisfaction with online courses, while 57% indicated that system quality required enhancement done at OR 2022. In Vietnam, cloud-based e-learning has played a crucial role in sustaining education activities. Nonetheless, limitations regarding infrastructure and technology still hinder learners' access. This study is set to examine the success of cloud-based e-learning to contribute to improving the quality of student educational experiences. Next, we go to literature review. So, e-learning. E-learnings refer to virtual learning conducted through computers or smart devices connected to remote servers. It involves pre-recorded lectures and software that facilitate asking questions, submitting requests, and taking exams online. Mayor Edward 2001. Cloud computing. Cloud computing is a form of computing that enables users to access information technology resources without the need to invest in building their infrastructure, for Catilu Edward 2010. Cloud computing has two primary components: application service provided over the internet with hardware and software support in data center, commonly referred to as clouds. Cloud-based e-learning. Cloud-based e-learning combines cloud computing technology with education, offering a cost-effective and flexible online learning infrastructure. This one at or 2012, educational material are stored on the servers of cloud, enabling students and educational institutions to easily access and grant resources. Cloud-based learning is not only a current trend but also an effective solution for educational institutions. IMER at or 2024. Information system, ISSS. Information system ISSS is described a theory that offers a comprehensive understanding of information system by examining the structural relationship among various asset concepts. This theory is assessed by system users at three levels and aims to enhance information system performance in supporting the organization's business objectives in 2018. Accordingly, the model of ISSS accentuated by Dallon and NC Flynn 2019 consists of different levels: system quality, system usage, and system impact. Next one, we go to the research method. The research process is divided into two stages. The first stage involves preliminary research using qualitative methods, and the second stage employs formal analysis with quantitative methods. During the first stage, a RAP scale is developed based on the theoretical foundation of the information system such as ISSS and other related works. This RAP scale is then reviewed by senior experts in cloud computing and in learning to enhance its content accuracy. In the second stage, the adjusted scale is treated at the official scale. This stage uses a 5-point Likert questionnaire, which includes 5 response levels: completely disagree 1, disagree 2, agree 3, agree 4, and completely agree 5. The questionnaire assesses the evaluation levels of the manifest variables. The main analytical methods used in the study are exploratory factor analysis (EFA), conformatory factor analysis (CFA), and structural equation modeling (SEM). The tools employed for the data analysis are SPSS and AMOS. About the data descriptive, data was collected by convenience method with the quota. Females have a slight advantage over males, with males and female participants representing 46.4% and 52.8% respectively. Additionally, the proportion of participants identified as older gender is 0.8%. Next one, this is about research result. About the measurement model assessment. The analysis of measurement model assessments were tested to ensure that the measurement fully represented the coefficient of determination following theoretical concepts. Accordingly, convergent validity, discriminant validity, compressed alpha, and composite reliability (CR) are analyzed. This is a table of confirmatory factor analysis indicates in correlation coefficients. And this is about the table 9 hypothesis testing result. So we have the research model. We have 3 independent variables, 2 mediating variables, and 1 dependence variables about class-based learning success model.
Sorry to interrupt you, ma'am. Your 9 minutes are over, so kindly wrap up.
Yeah. And now we have to go to the conclusion about research implications. The finding has shown that antecedent can explain about 28.3% of variation in system usage and 40.2% of variation in user satisfaction. The model can explain 41.5% of variation in cloud-based e-learning success. There is a very good explanation of the model, and this study enhanced the theoretical foundation by investigating the construct that represent the success of information system in general, while specifically enriching the understanding of class-based e-learning. About the management implications, the success of class-based of e-learning system is evaluated through both indirect factors such as information quality, system quality, and service quality, and direct factors including system usage and user satisfaction. As a result, the success of class-based e-learning system underscores the value of the education sector investment in technology to support learning and highlights the significant growth potential of e-learning in the future. About the limitation and for the work, the data was collected using a convenient sampling method, which meant as lack randomness. Additionally, this work only examined the structural relationship based on the IS success model without considering other related factors. And future works can refine the scale in more detail and will aim to expand the sample size while also collected random data. Furthermore, upcoming study will incorporate additional relevant factors that contribute to the IS success, thereby enhancing the explanatory power of the model. Thank you for listening.
Hello, ma'am. Can you hear me? What are the challenges faced for the student data if you want to secure and privacy of the users students data in your cloud-based e-learning system?
Sorry, can you repeat again your answer? Your question?
Okay. What are the challenges for the students data if you want to secure the data, student data? What will be the challenge?
Challenges between the student who I sorry because I can't clarify about the question the last part of the question.
What are the challenges faced in ensuring the security and privacy of a student data in cloud-based e-learning system?
Yeah, the challenges. I think that is yeah, when it's about the class-based e-learning system. When they sign up, we have to provide a lot of information on the class-based e-learning, and I think that is the challenges when we have to research and development about the methods to make sure that the data, especially about the personal information, have to be protected in the high level. So, some challenge, I think that is, yeah, some, especially about personal information. If we, if that system don't have a high level in security, the data, especially personal information, will be leaked out, and it will go will be leaked out, and I think that is one of the challenge. And yeah, that's all.
Okay, fine. Thank you.
Amita ma'am, do you have any questions?
Yes. What is the motivation to take up this research?
Yeah.
What is your motivation to take up this research?
what is your accommodation in
Yes. Why you choose this research?
because I choose ISSS model because it is the best framework for me to follow, and it has it is the best framework for me to follow, and this is a model that has completely factors to based on to have a research on.
Okay, that's all from my side. Thank you for the presentation.
Thank you.
Thank you, ma'am. Up next, we have Kevin with us now. So we'll proceed with Kevin's Valencia Aragon presentation. He's presenting the paper title. Just a second.
Okay. Good afternoon.
Just a
Sorry, can
second.
you stop sharing, please?
Yeah, you're audible. So he's presenting Educational Escape Room, a gamified strategy for teaching Ecuadorian cultural heritage.
Okay, let me present.
Yeah, you can share your
Thank you.
screen now, Kevin.
Thank you. Just a second. Can you see my screen? Okay.
Yeah, it's visible. Just
Okay.
on the slideshow.
Okay. So let's go.
Present the research, Educational Escape Room, a gamified strategy for teaching Ecuadorian cultural heritage. The authors are Hugo Arias Flores, Mirez Zapata, Kevin Valencia Aragon and Luis Aguirre Morales of Universidad Tecnológica Indoamerica. Introduction. In recent years, a new generation of educational technologies has emerged in classrooms, transforming teaching and learning dynamics. Thus, educational innovation encompasses multiple dimensions, including pedagogy, didactics, and the use of emerging technologies, all aimed at enhancing teaching and learning processes. This involves not only the adoption of active methodologies, but also the integration of emerging technologies that enhance interaction and critical thinking. According to Fullen and Langworthy, disruptive education demands a shift in the teacher's role, positioning them as a facilitator of learning who promote student autonomy, creativity, and problem-solving skills. Furthermore, designing these environments must prioritize personalized learning and adaptability to diverse student styles and paces, thereby fostering more inclusive and equitable education. In the current landscape, active methodologies linked to gamification have gained prominence in education, offering innovative strategies that positively impact learning. These methodologies aim to create new scenarios where students engage actively, allowing them to tackle challenges that require the application of knowledge through playful and collaborative approaches. One such strategy is the use of escape rooms, a gamification technique involving collaborative games designed with multiple clues, logical puzzles, and tasks that a group of students must solve within a limited time frame to achieve a common goal. The activities or challenges within the escape room must be carefully designed by the teacher, tailored to the specific needs and characteristics of the target student population. This paper. The primary objective of the study was to design and develop a sustainable course structure based on the ABI model, fostering cooperative and collaborative classroom management. To achieve this, we implemented the educational strategy of escape rooms to enhance learning and student engagement in the cultural and artistic education discipline, involving 6th grade students in basic education. Methods. The proposal provides a planned, organized, and structured document aimed at enhancing educational quality through the implementation of a sustainable education model. This model employs the pedagogical strategy of escape rooms to teach Ecuador's tangible cultural heritage to 6th grade students in basic education. The methodological approach used in this proposal is the ABI model, which includes the phases of analysis, design, development, implementation, and evaluation. This methodology is widely recognized in educational project planning and development, enabling a systematic and comprehensive approach to ensure the pedagogical strategy's effectiveness and benefits for students. During the analysis phase, student needs were identified, educational objectives established, and essential content for achieving these objectives determined. In the design phase, a comprehensive plan defining the instructional structure and methodology was developed, ensuring alignment with the established objectives. Subsequently, in the development phase, each didactic component was detailed and organized to ensure coherence with the prior design. The implementation phase involved deploying the escape room. Finally, the evaluation phase focused on gathering feedback about the program and making necessary adjustments to optimize its efficacy. Results. Analysis phase. In this phase, the perspectives of 18 teachers from 5th, 6th, and 7th grades of basic education were considered regarding the essential content for teaching tangible cultural heritage. In response to this need, a proposal was designed to integrate key skills, both desirable and indispensable, that students must develop in alignment with the curricular framework. Subsequently, in the development phase, each didactic component was detailed and organized to ensure coherence with the prior design. The implementation phase involved deploying the escape room. Finally, the evaluation phase focused on gathering feedback about the program and making necessary adjustments to optimize its efficacy. Design phase. The proposed escape room, titled La Ruta Escondida, Descubrindo la Historia, the Hidden Route, Discovering History, is structured around missions represented as dreams. In each mission, students assume a central role, aiming to help a child awaken. This child dreams about themes addressed in the cultural and artistic education subject, with the narrative unfolding in one of the parishes comprising La Ruta Escondida. To succeed, students must employ their skills and knowledge to overcome obstacles and solve puzzles. Progress in the game depends on answering questions and completing activities or challenges embedded within the storyline. Development phase. In this phase, educational content and materials were developed. Teachers were responsible for selecting the content required for the escape room. Implementation phase. During this phase, active student participation was essential. To implement the proposal, teachers encouraged engagement in the game, an activity students found highly appealing. Each student required an electronic device to access the online tool, which did not require downloads. Development phase. In this phase, educational content and materials were developed. Teachers were responsible for selecting the content required for the escape room. Evaluation phase. To validate the proposal, an observation checklist was administered to the 6th grade of basic general education. This evaluation focused on the escape room experience. La Ruta Escondida, Descubrindo la Historia is an integral component of the learning process concerning Ecuador's tangible cultural heritage. The objective was to analyze not only the level of student participation and comprehension, but also their ability to solve problems and work collaboratively. The results indicated that the activity generated a highly positive experience. Firstly, active and enthusiastic participation was observed among the students, who demonstrated a strong commitment to overcoming the proposed challenges. The interaction among participants was noteworthy, reflecting effective collaboration and teamwork that contributed significantly to the success of the activity. Discussion and conclusions. The results support the effectiveness of gamification and adaptive methodologies in education, though their implementation may vary depending on context and individual preferences. They also underscore the importance of ongoing teacher training and flexibility in selecting pedagogical approaches. These findings suggest that educators value instructional innovation and are willing to adapt their practices to enrich student learning experiences. Thank you very much for your attention. Contact.
Okay, moving forward.
Thank you.
Up next, we have Prajwal Shahane. He is presenting dynamic traffic signal operations. Prajwal, are you there?
Yes. Are you audible?
Yeah. Just a
Let
second.
me share my screen.
Yeah, you can share your screen now.
So is it visible?
Yeah, it's visible. You can start.
Good afternoon, everyone. I am delighted to present our topic, dynamic traffic signal operation, which is being presented by myself, Prajwal Shahane, currently studying in Pune Vidyarthi Grihas College of Engineering and Technology, SPBU University. So myself, Prajwal, and our co-authors are Swapnil Patil, Urvi Patil, and Usha Varke. So let's start with the contents. These are the contents we will be covering up in the session. So the introduction is about we know that urban areas today face increasing traffic congestion. So traditional traffic lights operate on fixed timers which don't adapt to real-time conditions. So this leads to unnecessary waiting, frustration, and inefficiencies. So our project introduces a dynamic system using image processing and a Raspberry Pi to control traffic signals based on actual vehicle density. So our research objectives are our primary objective is to create a smart traffic control system which detects traffic levels in real time using a webcam and processing images locally on the Raspberry Pi. Okay, the second goal is to identify ambulances and prioritize their movement by giving them a green signal automatically. So we aim to reduce congestion, minimize wait times, and build a system that is affordable and scalable in the future. So the literature review goes like the first approach we studied was a congestion detection system, which is introduced by Kaushik Mondal. So their method focused on calculating different density by measuring the speed of a vehicle and their average waiting time at intersections. So, moreover, it does not support real-time adaptiveness. Instead, it reacts based on the predefined algorithms and delayed data, which may not reflect sudden changes in traffic flow. So, in contrast, our system addresses these limitations by utilizing a Logitech C270 HD webcam coupled with imaging processing techniques and next review is along with AI and IoT based smart traffic solution, which is given by Rahman and Singh. So these systems rely on cloud based processing, where real-time traffic data is sent to the remote server for analysis before signal adjustments are made. So while effective cloud-based approaches introduce latency issues, as network delays can slow down decision making, especially in critical situations such as emergency vehicle detection. Our proposed system avoids these delays by performing local processing on the Raspberry Pi 4B. So the next part is about comparison factors. So our basically we have traditional system. We know that traditional systems are simple but lack accuracy and adaptability. And sensor-based systems are more accurate but expensive and hard to maintain. So our proposed system offers high accuracy, low cost, and easy scalability. Hence, it's also capable of real-time emergency response through ambulance detection. So these are main comparison factors. So the flow chart goes in the following steps. Like first, the has been started. Then a camera captures the image. Then image is processed and carried out by controller. Then the count of number vehicles in image is counted. So it afterwards it detects if there is vehicle congestion or not. Then operates the signal light accordingly. Then signal is bypassed when camera detects ambulances or even any VIP vehicle, and process is ended. So the next part is challenges that we face in traditional system. So as we know, in traditional traffic signals, we have fixed timing signals, traffic congestion, and emergency vehicle delays, and a lack of real-time monitoring. So in the future scope, we see that we can integrate IoT sensors and AI to improve prediction and decision making. So with V2X communication, vehicles could communicate directly with signals for better coordination. And integration with smart cities, a mobile app for real-time data and cloud support can make the system more robust. Also, finally, using solar power and low energy AI chips would make it environmentally friendly and energy efficient. So conclusion is to conclude, our system offers a smart, low cost and efficient solution for the urban traffic problems, which is adaptive and prioritize prioritizes emergency vehicles and reduces congestion through real-time image processing. So this project demonstrates how combining AI and IoT and computer vision can reshape traditional infrastructure to meet modern challenges. So that's all from my side. Thank you.
Am I audible?
Yes, you are audible.
What are the research gaps you have identified while recognizing this as a problem statement for your research?
So basically, we know we have traditional systems which lacks in the real-time monitoring and like useless timing sessions for the traffic. And as we know, we have fixed timing slots for the traffic. Even if there is no traffic, we have to follow this timing, which causes uh, problem and time constraints.
Okay,
And also for emergency vehicles, it lacks for their convenience.
that's all from me. Thank you.
Okay, thank you.
Thank you, Prajol sir. Thank you, ma'am.
Thank
So
you.
all the presentations are done. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being part of this international conference. I hope this session was informative enough. We, on the behalf of whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2025. I thank our session chair, Dr. Amita Sharma, for chairing the session. A token of appreciation to chair on the behalf of Team ICICT 2025 and Global Knowledge Research Foundation and partners. I also thank our second session chair, Professor Deepali Nikam, for chairing the session. A token of appreciation to chair on the behalf of Team ICICT and 2025 and Global Knowledge Research Foundation and partners. Ma'am, do you have any closing remarks?
No, sir.
Okay. Amita ma'am, do you have any closing remarks?
Just I want to wish all the best to everyone and thank you so much.
Okay. Thank you for your valuable presence. I kindly request you all to switch on your cameras for a quick snapshot for a virtual conference. Thank you all.